All right, so let's talk about quadratic equations. So I'm going to split this into a few different videos. Try to keep these a little bit shorter because I know in particular you're going to want completing the square. You're going to want all of that to be in just one place, and that'll be really convenient for you, I think. A lot less rewinding and looking for things. These two are probably pretty familiar. So you're probably pretty comfortable with that already, but I might as well split this into two as well. So we have like 4 different methods. 2 of them always work on any quadratic equation. 2 of them are just only for special ones. If you're lucky, these 2 are easier and faster if it jumps out at you. And this other one is kind of related to the quadratic formula, the discriminant. Well, anyways, we'll talk about that when we get to it. But that's sort of the outline. So most of this video should be kind of old news. If you're already really good at these, then you can just try to do those problems and it won't be a big deal. But doesn't hurt to review. I'll try to keep it kind of fast here. First of all, a quadratic equation is a quadratic equation is maybe it's already in this form, or maybe you have to do some extra work to rearrange it. So what you do is you make sure one side is 0 and everything else is on the other side. And if a is just 0, then it's really just a linear equation. And those are a lot easier. This is we don't really call that quadratic if a is 0. So with that one technicality in mind, if it's like that, that's just linear, and that's easy enough to deal with. It's a little bit trickier. It's not immediately obvious how you solve these. Someone had to do a lot of work to come up with some of these methods here, but so let's sort of start with some of the basics here. So x minus 1 times x plus 2 equals 0 is quadratic equation because it's the same as x squared. Well, you should be you should go to we've practiced this recently. You should be able to do this. It might take you a minute if you're not super duper fast, but the very first homework that we actually turned in had to actually do some work, included some of these because it's really important, and I really hope we're up to speed on that. But here we have a minus x, we have plus 2x, we get exactly 1x left over. That's the left-hand side. And the right-hand side is 0. So a equals 1. This is a little bit overkill, but it's good practice because like usually you can do this just by looking at it. But if I'm being really formal here, then sure. When we get to the quadratic formula, identifying these numbers as A, B, and C is pretty important. But that's a lot of mathematics is pattern recognition, and well, there's more than one way to say the same thing, but our standard tools are going to assume that we have it in. Actually, let me go ahead and write it down. This is called the standard form. So that's what that looks like. So that's just verifying that this is a quadratic equation. Being a little bit formal with the definitions here. So let's take this example that we're working with right now and solve for x. Well, actually, the way that it was originally given to us was very, very nice because there's this thing called the zero product principle, and that is, well, it's very important that the other side be, something times something, A times B equals 0. So two things or three things multiplied. If you multiply two or more things and you get 0, then it's the same thing as A equals 0 and or one of them, maybe both. So it's the only way that you can multiply two things and get zeros is if one of those two things is 0. So if one of them were not 0, you could just divide by it, and then the other one left over would have to be equal to 0. So what do we get? We get x minus 1 equals 0, or x plus 2 equals 0. Sorry, there's just an equal sign here. So x, in this case, x, you subtract 2 from both sides, x has to be negative 2. If you add 1 to both sides, then I guess I should put this all as and I think on my lab it's going to ask for the solution set. So we use, because it's not an ordered pair, it's not a point on a graph. These are just two different numbers. So it's just this number is one element from the set of solutions to this quadratic equation. But there's also another one. So that's all we're looking for here. Okay. So another example. Let's see. All right, let's do this one. Yeah. Okay. Yeah. So let's see. Yeah. All right. right, so this one, you sort of just have to be a little bit careful here. And that is, well, if there's something on both sides of the equation that if you don't have 0 on one side, then it's not in the correct form for most of our methods. And then factoring, well, it has to well, the leading term the coefficient is 1. And so now this is the factoring method you want is like 3 out of 4 of our methods require standard form before you begin. And then this is actually the same problem as the last one at this point. So solution set. If you're doing MindLab, you have to make MindLab happy. The way I wrote the instructions, I don't think I was too specific about this, but for MindLab, if it asks for the set of solutions, then that's what the set is. So that's all we're looking for here. So yeah, I don't want to say too much more about that. You might want to brush up on your factoring if you want to go back to the lecture about factoring and the homework assignment. Put those two parts together, you basically have everything you need here. Yeah, let's maybe do let's maybe I'm doing kind of quickly here. Which one did I? There was one that I liked. Where was that? Oh yeah, that one. Okay. Okay, so it's this one. It's not given in standard form, so you get to watch out for that. You don't want to. This isn't C is not equal to 2. It's actually C is equal to -2, because when you write everything on one side instead of equal to 0, there's a -2 here. And so factoring the x out on the left-hand side does not accomplish anything, because factoring only helps when the whole thing is equal to 0. And now we can start factoring. So there's a couple ways you can do it. You can factor by grouping, or you can just guess the coefficients. You know that they have to multiply to -2, and you have to multiply to 3, and then there's various, where do those numbers, where do they go, and you can guess and check a little bit. So what do we actually end up with? And one of them is a plus and one of them is a minus, and then there's a 2 and a 1. But which one is plus and which one is minus? Does the plus go here? Does the plus go here? Well, let's see. We want 3 versus 2 would give us 1, so here we get plus 3 x's, and then minus that would give us, whoops. Sorry, I said I needed -2, so it has to multiply to -2, so one of them has to be negative, and one of them has to be a 2, and the other one has to be a 1, but here we go. So there are only a few different ways that it could be, and that's the one that worked out. And that's it. So then 3x minus 2 is equal to 0, so 3x is equal to 2. Divide by divide both sides by 3 to get x is equal to 2/3. And then x plus 1 . So there's two different cases here. There's two ways that that product could be equal to 0. So one of these, or maybe both, could be true at the same time. It turns out that no, they give two different solutions. So solution set is, there's a -1 and there's positive 2/3. And you can actually check that. If you plug in a -1, you get 3 minus 1 is equal to 2. And then if you plug in 2/3, you would get, let's see, that would be like 4/3 and another 2/3 minus 2 is equal to 0. So same thing. So yeah, pretty good. All right, and then square roots. Well, now this is, now we're getting kind of closer to how we're going to solve these kind of in the future. So so factoring is great if it just happens to work out, but we know that that's not the whole story. So for example, 2x squared is equal to 3. So let's solve that. Well, x squared would have to be 3/2. And we know that, well, there's only one square root function in the calculator, which gives the positive square root, but we know that the negative square root is also equally valid as as a solution to the previous line. So if x squared is 3/2, then x could actually be either the positive or the negative square root, and we would get, if we were to square this, either one of these would give us the same thing. And in particular, MyLab, when it asks you to compute things symbolically, it doesn't like square roots in the denominator. This is kind of an old-fashioned sort of thing. There's some reasons why it's kind of interesting, and we're gonna take a little bit of effort to write things in a standard form. So we're going to get rid of the square root in the denominator. If there were a cubed root, we would have to, we would have to multiply until we got a third power of the thing that's cube rooted, but it's square root, so we only need 2 copies of that square root. The numerator we can't simplify any further, but now the denominator is just plain old 2. The numerator is, if you have the square roots of 2 different positive numbers, you can combine that square root into a square root of the product. So you can see this as the square root of 6 divided by 2, or maybe that you would write it as 1/2 of the square root of 6. So this is kind of a standard form of the answer. This is called rationalizing the denominator, because a square root is an irrational. A square root of something that's not a perfect square is actually going to be this irrational number. It cannot be, square root of 2 cannot be written as a fraction, so the final answer has to have a square root in it somewhere. But this trick says that, well, we don't have to put square roots in the denominator. We can rearrange things, so we always can write a square root of a fraction as a fraction times a square root of a whole number. And that's also kind of an interesting fact about how numbers work. All right, so I just want to do one more of these, and this is kind of gonna foreshadow, give a little preview of where, why do we do completing the square and stuff like that. So we have 3x minus 1 squared minus, let's keep it a little bit simpler. These numbers are going to be a little bit nicer. Well, this is actually not as hard as it looks. If you don't multiply it out, well, the only place that we have x is right here, and it's a perfect square, and it's actually pretty nice. So what do we get? We can just add 12 to both sides. We can divide both sides by 3. The right hand side is 4. The left hand side, the 3's cancel. So x minus 1 squared is equal to 4. We're a little low on space, but it's almost done. X minus 1 is equal to plus or minus the square root of 4. So x is equal to 1 plus or minus 2. So x is equal to 1, or x is equal to negative 1. That's the solution set. That was over the previous problem. Sorry, we have solution set. That's for this problem here. Okay. But that's the square root method. So that works only when you have ax squared is equal to constant. Well, here, if you've got a perfect square and that's the only place you see x, if it's either x squared or x minus h squared, that's really good. You put the constant on the other side, you divide by a, and then you take square roots of both sides, and then what you're left with is, well, you have two different cases. You have plus and minus, but it's pretty straightforward from there. And that's so the key here is that's why, you know, this problem is pretty straightforward. If it were all multiplied out, it would be complicated. So this problem is simple. Well, what if I were to multiply all that out? Well, if we're x squared minus 2x plus 1 minus 12 is equal to 0, I'm just saying this problem is a lot harder. So 3x squared minus 6x, you end up with plus 3, and then minus the other 12 is sort of harder. Well, this one's not too hard to factor. The numbers are pretty nice. But well, that you have to do something. You have to like factor it or whatever. So if it's in this form, that's really nice, and that's the whole idea behind completing the square. So we'll get to that eventually. That's it. I said I was going to cut this one a little bit shorter just so to break it up, and that's what we're going to do.